Yeah, hi Abhijit. So let's wait for a couple of minutes more to join others, and after 2-3 minutes, we will start. Okay, so let's start. So today we have uh, four problems related to the dynamic programming concept. So I'm publishing all the problem at a time, and we will discuss one by one each problem. Okay. So can anyone confirm problems are visible on Rapid team? Just refresh your page. Am I audible to all? And my screen is visible? Yeah, Mayank, Abhijit, Nidhi, anyone can reply?
Yes, sir, your screen is visible. And
Okay, thanks, Mayank. Yeah. Okay, I have published all the problems. So we will start from the problem number one. Okay, I'm also opening the what is the problem. Yeah, so first problem is basically related to the coins. So the problem statement is that given a value v, if we want to make a change for v cents, and we have an infinite supply of each of coins. So we have coins with value c1, c2, dot cm. Okay. and what is the minimum number of coin to make the changes. Okay, so we have a total value v, and we have different types of coins. C1, different types means different valued coins, C1, C2, cm, and there is a no limitation to select of these type of coins. We can select C1 many number of times if required. Same for all. So what is the minimum number of coins to make the changes? Okay, so what is the minimum number of coins required to make this value v? So write a function min coins where there are two parameters, coins and v. So coin is basically a list of coins with different value, and v is a total value which we require to make by coins, that returns the minimum number of coins to make the changes. If it is not possible to make a change, then return -1. So this is a problem statement. For the first problem statement, and now you can think about what concept you should use for solve this problem. So if anyone want to share your thoughts, what's logic or what's concept comes in your mind first after looking this problem?
So we need to find the right combination. I mean, so we will see each point and we'll see how we can achieve the V value with that point or any combination of these points.
Yes, yes. So number of coins should be minimum. That is our
Yes.
main goal. Okay. So if you look the first input sample, so we have three different valued coins. So we have a coin with 25 value, 10 value, and 5 value. Okay, so and our total v is equal to 30. So how we can select the coin? So we can select one coin of 25 value, and we can select one coin of 5 value. So we can achieve this value v in 2 coins. Okay.
So we can choose any number of time, a particular.
Yes, yes,
I mean,
yes.
I can. Okay.
Yes. So any number of times you can choose 10 any number of times. So for example, if you are achieving this 30 value by 10, so you can select 3 coins with 10 value. So there is no limitation to select the coin, particular coin. So by first look, actually this problem looks a greedy based problem. Most of the time, students solve with this solve this problem using the greedy approach. But greedy approach failed in some corner cases. So maybe some test case could be can be passed using the greedy approach, but not all.
Sir, how should we break this into sub-problem?
Yeah, so yeah, that things I will discuss. I will discuss the full approach with the example how we can break this problem into sub problems. Okay, so I'm discussing this basic idea of to solve this problem using the DP concept. Then you need to convert this idea to code. Okay, so I'm taking one example. So for example, I'm taking second example. First example, if you see that we can solve using a greedy approach, just sort the coins according to the in the decreasing order, and then select the largest coin first. If we are achieving the value, then that is final. Otherwise, we will move to the next coin. So this is not a perfect input. I'm selecting the next second input to show the example. Okay, value is 11. Okay. So now, so we have total value v equal to 11. Okay, and we have 4 coins here, 9, 6, 5, and 1. Okay, so now we will create a list. We will create a list uh, for to find the value. So we will create a, for example, t table we are creating. So here we have total value 11. Okay, now we can divide this value in a we can divide this value 11 into it 11 separate value. So I'm starting from the 0. So 0, 1, 2, 3. Sorry. So this is the index actually. So 0, 0, 1, 1, 2, 3, 4, 5, 6, 9, 10, 11, and one more. So okay, so I'm representing the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, one more 11. Okay. Okay, so I breaks this value v equal to 11 into 11 separate value. Or we are taking a 12 value here. We are also considering this 0 value. Okay, so think about this. This index is representing a v here. Okay, actually our main goal is to find the minimum coin for value 11. Now we will start from the 0 value. Okay, so I'm just dividing this main problem into a sub problem. So initially number of I initialize with 0, but actually we are finding a minimum number of coins. So we have to initialize the highest value in each field. Okay, so using this we can find out the minimum number of coins. So initially I've just initialized with 0, but I will just initialize the first 0 value by 0. Otherwise I will replace all 0 by infinite. I'm assuming that the number of coins is required for one value is infinite, two value is infinite, this type of thing. So this is the initialization only, and then I will solve step by step. Okay, so I'm just I and I like this thing. Okay, now this 0, 1, 2, 3, 4, 5, 6, 7. Awesome. I have to write every steps. 7, 8, 9, 10, 11. So I am so this is the initialization. We are assuming that if our value is v, if our value is 0, so this 0 value cannot be covered by these coins, any number of coins. Okay, so there is no for 0 value, if our capital V equal to 0, so that means there is no coin required to achieve this 0 value. So because of that, I am just initializing this value 0. After that, we are just assuming that if our capital V value equal to 1, so I'm assuming that total number of coins is required is infinite. We are just taking a maximum value. After that, we will find out the minimum number of this for 1. So this is the initialization. Now we will find out how we can find out these things, the total minimum number of coins. So we will start from the 1 index. We will start from the 1 index, and we will check that how we can achieve this 1 value using this coins. Okay, we will just traverse all the coins, and we will check that how we can achieve this 1 value and how many coins are required. Okay, so now in the next step, for value 1, for v equal to 1, this index 1, so first value is 0. So for this value 1, so this is a sub problem actually. I am just considering that we have only one value. So this is a sub problem. This is a sub problem. I am just considering that we have v equal to 1. So for v equal to 1, how we can find, so we will traverse all the coins value one by one, and then we will check that. Uh, so using 9, so for example, for first coins, can we achieve this value? No, because this 9 is greater than this one. Okay, then we will check the second coins. This contains a 6 value. Okay, so 6 value, but if we select this 6 value which is greater than this 1 value, so we cannot select this. Same things we will check for 5. Now this coins contains a 5 value, but we want to achieve only 1 value, so this is also not possible using the 5 value coins. Now the last coins contains a value 1. Okay, so if we select this 1 value coin, so we can achieve this value 1. So total number of coins is required is 1 here. Okay, so we have solved this first problem. So first sub problem we have solved. Okay, now we will solve the second sub problem. So now we have solved for 0 and 1. 0 have 0, for 0 we already know there is no coin required, but for 1 we can achieve this 1 value by 1 coin of 1 value. Same for now second index. Okay, so for value 2 we will repeat this step similarly, and now we will check that this 2 value can be achieved by this 9 coin. No. 9 valued coin, no. 6 valued coin, no. 5 valued coin, no. Now we can achieve this 2 value by this 1 value coin. Okay, so we can just check that. So we have a value b equal to 2, and we have 1 coin 1. Okay, so coin value is equal to 1. So we will select 1 coin. So that means we will select this coin, only 1 quantity we will select only. We will select only 1 quantity, and then check after selecting 1 coin of 1 value, what is the remaining weight. So what is the remaining weight is v minus 1 coin of c. So this is basically we can write this 2 minus 1. So what is the remaining weight is 1. So we will directly check how many coins are required for 1 value in our previous list. So we have already calculated this thing. So we have already calculated the number of coins is required for the 1 value is 1. Okay, so we have selected 1 coins from in this. So from this first case, when our v is equal to 2 and coin value is less than 2, so we are selecting 1 coins, and then the remaining coins for remaining value we will just check the previous value. What is the remaining value? We will just check the index of this one here, because we have already calculated this part. So we will directly read this value. So for value 1 only, so 1 coin is required, so we will add these things. So we have selected 1 coin here. Now so we will read the remaining value part from the previous sub problem solution. So the 1 plus 1, so 1 plus 1 is 2, equal to 2. So now we will put these things here, 2. That means for 0 index 0, 1 index 1, now this 2 index, so for 2 value there are total 2 coins are required maximum, sorry, minimum. Okay, now this part is solved. Same process we will repeat for value 3. Okay, 0, we have this previous part we have already solved. Now we are just finding out the value for 3. 2, so for 0, 1, 2, 3. Now I'm finding for this. Okay, so here value equal to 3. So here v equal to 3. Okay, now we will repeat our process, same things. So we will just check this 3 value can be achieved by the coin of 9 value. No. By 6 value coins, no, because it is greater than this. Okay, so 5 value coin we cannot select because value is greater than this our total value b. Now the same things 1. Yes, so this 1 value is less than our total required 3 value. So 1 is less than equal to 3, this condition. So for this coin, this condition is satisfied. Now we will select one coin. Now we will select one coin directly. And so after selecting one coin, what are the remaining weight is? So v minus 1. Okay, so v minus 1 is 3 minus 1 and remaining value is 2. Now we will check the total number of coins required for 2, which we have already calculated. Okay, so this is the 1 plus. So we will check this thing directly in our previous solution. Okay, so we have already calculated these things. So total number of 2 coins required for achieving 2 value. So we will directly add this thing 1 plus 2. This 2 values we will read from the previous solution. We are not solving this part again, because in the concept of dynamic programming, we just use the solution of previous subproblem. So we have already calculated the coins required to achieve the 2 value. So we will directly read these things in our table. So we will directly read this 2 value from here, and we will add 1 in this. So 2 plus 1 is 3. So this is the solution for 3. So now we have solved till 3. Same for 4. If we talk about this 4 things. Okay. Now same for 4. So we cannot find these 4 things using 9, 6, 5. Same for, so we will repeat the same process again using 1. We will select 1 coin from here, and the remaining weight 4 minus 1 is 3, and we have solved the total number of coins required for 3 already. So we will directly read the value from there. So 3 plus 1 is 4. Okay. So now till now, this is the simple part. Now we will move to the next value, 5. For value 5. Now this time, so we have total value v equal to 5. Now we will start from the 9 coin. So we cannot achieve this. From 6 value coin, we cannot achieve. Now the third coins that contains the value 5. Okay. So we will select this coin this time. So this coin we will select. 1 coin we will select. So we total value we have 5, and we are selecting a coin which contains a value 5. So 5 minus 5. The remaining weight, remaining value is now 0. Okay. So that means we can achieve this thing. So we will we will read these things. So for remaining value 0, how many number of coins is required? We will directly check this in our table from here. There is no coin required, so 0. So from here 1 coin, and from here 0. So 1 plus 0 is 1. Okay. So we will repeat this process for every value. Okay, so for 6 example, for next value 6, we will repeat process, same process again. So 9 coin we cannot achieve this. From 6 coin, 6 value coin we can achieve this. So we will select 1 coin of 6 value, and the remaining weight will be 6 minus 6 is 0, and we will check the coin required for 0 is 0. So that means we can achieve this 6 value in 1 using 1 coin. Same for 7. So 7, for 7 we will start from the 9. We cannot achieve this 9. Now for 7, so 6 is less than 7. Okay, so we will pick 1 coin of 6. So for 7, so if v equal to 7, we will pick 1 coin, c equal to coin 6. That means 1 coin is required for the 6, and after the remaining weight will be 7 minus 6 equal to 1, and we will directly check that.
One second, sir.
Yeah.
When we are doing for 7, so we are going in the dictionary from left to right. So we will first select 1, and then remainder will be 6.
We are not reading dictionary from left to right. We are reading from left to right. So first coin is 9.
Okay. In the value. Okay,
Okay.
sir.
So in our list, we are starting from the initial. So always we will first check for 9. So 9, using 9 we cannot achieve this. Now we will check for the second 6. Yes, 6 value is lesser than 7. So we can select one coin of 6 here. Okay, so after selecting one coin of 6, the remaining value will be 7 minus 6 equal to 1. So for this one, we can directly check the solution in our table. So total number of coins required for 1 is 1. So we will directly add these things, 1 plus 1, 2. That means we can achieve 7 using 2 coins. Okay. Same for 8. So 8, same things we will repeat from the starting. Yeah. Okay, so in our so for the previous 7, okay, so some others solution is also possible. So if we get the lesser value, so for example, after selecting 6, we will also check for the 5. Okay, so for 5 we can also achieve this thing. So v equal to 7, and we can 5 is also less than this 7. Okay, so we will select one coin of 5 value, and the total remaining value is equal to 7 minus 5 equal to 2, and then we will directly read the solution of 2 is 2. Okay, so one coin from here, 2 coin from here, so total is 3. But this 3 value is 3 value is greater than this 2. Okay, if so we will always update our coins number if it is lesser than the previous value. So because of that, we first initialize with the infinite things. Okay, same for the 1, same for the 1. So if v equal to 7, if we select the coins, one coin of one value, and the total remaining weight will be so 7 minus 1 equal to 6. Okay, this is so we will directly check the solution for 6, this which is 1. Okay, so we can also achieve this. Yeah, we can also achieve this. So this is also a 1 plus 1 equal to 2. So 1 equal to 2. So which is also equal. So if we are getting lesser value by compared to the previous value, so we will update. So now for 8 value, if b equal to 8, now we will check from the starting, we cannot achieve by 9. So okay, we will select the one coin of 6. So one coin of 6, and what is the remaining things is, so 8 minus 6 equal to 2. We will directly read the solution for 2, which is 2, and we will add these things, 1 plus 2. Total coin is required 3. Okay, so 3 is lesser than the previous value infinite, so we will update these things 3. After that, we can also achieve this 8 value using after selection of this 5. So one coin of 5, and remaining weight is 3. So 3 we can find from here. So 3 is required. So 1 plus 3 is 4. 4 coin is required if we are selecting 5 first. So this 4 is greater than this 3. So we will not use this. Okay. So when we find the minimum lesser value compared to the previous value, so we will update these things. So same for, we will repeat for the 9. Yeah, so for 9 value, the first coin if we are selecting, so that means one coin we are selecting of the value 9. After that, remaining value is 9 minus 9 is 0. So for 0 coin is required. So 1 plus 0 is 1. That means we can achieve this 9 using the one coin. Okay, same for the 10. If we want to achieve this 10, so we will start from the first 9 value. So 10, we can select 9, one corner of 9 value. After that, remaining value will be 10 minus 9 equal to 1. So 1 we can achieve using one coin. So 1 plus 1 is 2. Now the next 11, this is the final. Okay, so this is the final which we want to solve. So for 11, we can start from here 9. Okay, we are selecting one. Okay, this is the final version. Okay, just wait. So for 11, yeah. So for 11, if v equal to 11, so we can select one point of 9 value. After that, remaining value will be 11 minus 9. So this is 2, and 2 value we can achieve by 2 points. So 2, we will add this 1 plus 2 equal to 3. So by the first step, this 3 value come here, but after that, if we are selecting 6, okay, if we are selecting 6, so for example, if v equal to 11 and we are selecting 1 point of 6, okay, so what are the remaining weight is? So what remaining weight is 11 minus 6, which is 5. So what is the solution for 5 is 1. So we are selecting 1 point from here, okay, and for this for achieving this 5 value, we can achieve this 5 value using 1 point. So 1, we are getting 2. Okay, so this 2 is lesser than the previous value, so we will update this. Now, so next, if we are selecting v equal to 11 and we are selecting one, so 5 value coin, 1 coin, and remaining value equal to 11 minus 5 equal to 6. So same things for 6, that means 1 coin is required. So 1, we will add these things 2. So 2 is equal to the previous value, so we will not update this thing. And now next one is also possible. So v equal to, if we are selecting one coin of one value, and the remaining values are equal to 11 minus 1 equal to 10. So for solution of for 10 is 2. So we can add these things, 1 plus 2 equal to 3, which is greater than the previous value. So this is the final solution, and we will return this value. Okay, so you can see we have divided this v into a sub problems of the 11 sub problems, and we have started to solve from the initial things. So we have started from the 0 value, 1 value, 2 value, and we use the solution, previous calculated solution for the solution. So how we can convert this procedure into our code? So this is a dynamic problem solution for this problem. So for if for example, if we are taking any value which cannot be achieved by the given coins, so definitely in the final answer, our this infinite will remain same in our final table. We will get the infinite things. If we are getting infinite value for our final v, so that means we will return the -1. That means we cannot achieve this value using our given coins. So these are the things. So this is the initialization part. So you can create a table T, and you can just initialize with this value 0 in inf. So for inf, you just can use the things inf equal to float inf, float inf. Okay, so for maximum value, you can directly write in Python. You can take a variable inf equal to float in bracket, you just write the inf in string format. So there is one infinite value will be assigned. So this is the initialization. After that, just create a loop and solve using these things. Just apply the logic in the code. Okay, is it clear? Concept is clear. How we are solving this problem using the DP concept.
Yes, sir.
Okay, so try to write the code for this. Okay, so I'm just checking that how many of you are writing.
Hello, sir.
Yeah, Sanjeev.
Sir, which problem?
Problem number one, week 9, problem number one. We have already published. You can go to on the Replit team and you can start. So we have already published all the 4 problems of week 9, and you can start one by one from the first problem. So everyone, you should try the DP problems. These are the important problems with respect to the your final OPP exam. So those who are joining late, if you are not in the team, Replit team, you can ask in the chat. I will send the Replit team link in the chat box. If you are not joined in the Replit team. So if anyone, if you have completed the problem, so just please send the message in chat box. If you are facing any problem to understand the concept, you can ask in between.
Yes, sir.
Just return your answer. Your solution is looking correct.
Okay.
Okay, just go outside the loop and just return the last value of the table.
Okay.
Yeah, so one more thing, Sanjeev, there is one more condition is given. If the coin, if the value cannot be achieved by the coins, so you should return the -1. So before that, before this return, just check that if table last value of the table is infinite, just return -1, else return this last answer. So before this return statement, just write that if for table -1 equal to INF. Yeah, then return -1, else return table last value. Okay, can you run? Yeah, passed. Yeah, fine. Your solution is correct. Check correct. Yeah, very nice. Okay, so to have solved completely this problem, so this is the solution we can see from the Muhammad Amir template replit. So yeah, he's just initializing that one list T for store the subproblem solution, and he's taking one INF variable for the infinite value. After that, he's just initializing the table with infinite value, and after that, we are just initializing T0 equal to 0. So same process we are repeating here for each value from the value 1. We are just checking that how many coins are required. So we will check that, we will read the coins from the coins list and check that if the value of coins is less than our required value, then we will find out the remaining coins. So after value minus coins, okay, so we are selecting one coins for particular value. After that, for the remaining value, we will directly read the number of coins in our tables, which we have already solved previously. After that, we are just adding remaining coins plus 1, so that means 1 for coins, and these are the value for the remaining coins. If it is lesser than the previous value of in the table, so we will update these things. After in the final things, we will check that for the final value capital V, if TV equal to INF, that means this is not possible to achieve this value using the given coins. So we will directly return -1, and then finally, if it is possible, then we will return the T capital V value in the table. So that is the answer. Okay, nice, Mohammed Amir and Sanjeev. Yeah, others are also trying. So those who have solved, you can move to the problem number 2. Yeah, Mayank. So your code is looking correct. You can just change the small things.
So actually, I'm getting index error. Uh,
Index error you are getting.
Yeah.
Okay. So actually, you have initialized the main coin count only for 10 value actually. So one just initialize with from the 0 and just initialize the first value as a 0. Yeah. So after that, just write min count 0 equal to 0. Equal to 0. Yeah, this is the for the first. Yeah.
So what is the use of 0? We are not going to use 0 anywhere.
You are not using okay. Yeah, actually you have taken this condition. Huh? If you are getting one value, so if you're getting the count exactly same. Okay.
And minimum is 1. So that's why I thought.
Actually, the because error is coming. So okay, 1 second. Remaining I minus coin. So the coin things. Okay, just check the error. What error is actually coming?
So actually, it is coming at.
Just some test
Oh,
case.
now, okay. Now it's, yeah, I'm not getting index error. I'm
Yeah.
getting different.
Okay, so these things I am not getting. Why you are using these things? Temp equal to 9999 here.
So actually, I was facing some difficulty in assigning infinite value.
So
So that's why.
infinite value is fine here. So INF is okay. And okay, so we just check the count equal to min count remainder. This is okay. Okay, so this part you can remove, I think.
Okay.
So INF equal to min count. This part is not required. No. Just okay. 1 second. If temp, yeah, just write this thing.
So this is what I was doing earlier.
Okay, so for 1 second, yeah, for I, actually, we are taking this I. So just write here I.
Here.
Yeah, I. Oh.
But we have to check for.
No, actually, you are comparing here. If temp is greater than equal to count, then you are just assigning the I value. So read the I value in the temp. Yeah.
Okay, I got one.
Okay, and there is
So
one
my.
condition is remaining. Just check that if the last value of the table is infinite, then return -1 because this is not possible to make this value using the given coin. So here just write that if min coin count equal count v equal to IN, just return -1.
Yeah, it passed.
Yeah, now it is passed. Okay. Okay, fine. Okay. So move to the second column. I'm explaining that how we can solve the second. And Bimbles is also pending, I think. Okay. Yeah, Bimbles. So I think you are facing difficulty.
Yeah, good evening, sir. Actually, I was wondering whether I could use recursion in this, but it seems.
You are solving this recursion methods.
Yeah, but I think it's not connecting. thought was like I initiated the array, and after that I changed from 0 to -1, saying that none could be achieved. And
Okay.
then I was updating one by one
Okay,
in the
okay.
array.
So yeah, that problem can be solved using the recursion method. If you are using the table here, so same things, the memorization approach, I think you are using.
Mhm.
Mhm. But actually, the finding out the logic of the recursion is more typical sometimes. Okay. If you're getting some logic using recursion, you can try. Otherwise, you can
So I'll try
solve
that.
using the
Otherwise,
DFT.
I'll change the logic. Yes.
Yes. Okay. So I'm moving to the second problem. So this is a second problem related to the DP concept. So a subsequence. So you have already learned the subsequence topic in the B9. So you know the what is the subsequence is. So after that, write a function count subsequence from S. Okay, that accepts a string S which contains only digit characters. The function returns the number of non-empty subsequence that can be obtained from S, such that every digit in the subsequence is strictly greater than all previous digits if exist. Okay. Okay, so there is noise actually. Okay, so here some one example is given. So we have one string S that contains the integer value in it. That here the integer value can be repeated, any number can be repeated. So for example, 7598, and discussing example. So S equal to 7598. This is a string, but actually we want to find out that how it's a total number of subsequence from this string where the value is in increasing order. Okay, if more than two digits, so value should be in increasing order. Okay, so this is the condition of the subsequence. Okay, so every digit in the subsequence is strictly greater than all the previous digit. Okay, that means increasing order. So how many order are possible for this is? So we can write one subsequence like 7, 5, 9, 8 for each single digit. This is one possibility. After that, so we can find out that, so we can write that one subsequence like that 5, 9. Okay, there is one possibility. 5, 8 is also possibility, and 7 and 9 and 7, 8. Okay, and 7. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So I think this is the answer for the first sample. Yeah, 8.
7 5 can't be right.
7, 5 we cannot write because 7, 5. So their second value is smaller than the previous value.
Okay, okay.
So every value in the subsequence should be strictly greater than of the previous value if previous value exists. Okay. So how many number of subsequence are possible? This is the question. Total number you have to return. So how we can find these things? And in subsequence, you cannot change the order. Okay, I think you all know these things. So in subsequence, we cannot change the order. So we cannot just write that 5 and 7. Because Okay, so in our original sequence, 5 comes after 7, so we cannot change the order in subsequence. Okay, order should remain the same. So this is the problems. Now how we can solve this using the DP methods. I will explain these things. Okay, so I'm explaining the logic of the DP. So this strings can be created using a digits. So how many digits are possible in our strings? So we have total 10 digits are possible. So okay, I'm creating one list here. So for example, I'm creating a list count, and it contains 10 value. So here we are just finding out the total maximum number of subsequence. Okay, so we will initialize with 0 all. Okay, so 0. So we will insert 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we are initializing with value 0 for all.
Why do we need 10 digits actually for this one?
Actually, in the problem statement is it is given that our string is made by the digits. So how many types of digits possible? So only 0 to 9 digits are possible in our strings. Okay, so because of that I have taken this information. So 0 to 9 initially. Actually we are just creating a sub problem, and we want to find out that the counting of each digit, if it is coming in our sequence. Okay, so initially we just consider that we have counting of each digit is 0. Okay, 0 to 9, we are just initializing that our total number of countings is 0. Now we will start from the first digit. So just we will create a one separate list, and we will split all these numbers in our list. We can just write like this thing. So 7, 5, 9, 8. Now this is the integer number actually. Okay, we can convert these things easily using the typecast. Just read each character and just convert it into an integer value. So I have created a list of each numbers. Now we will start from the first value. Okay, so first value is 7. So for 7 value, we know that our subsequence are possible with a single character. Okay, so our first single character is possible with the single integer number. So 7, if we are taking 7, so we will check the counting in our counting list. So we will check that what is the counting number in our list. This is 0. We can increase by 1 here directly because we can take single 7 in our final answer. Okay, so one value we can easily increase. So for example, we have increased 1 here. After that, we will check that is there any update before 7 have been done in the count list. So we will check for all 6 to 0. 6 to 0 for all value. We will check is there any count value we have already updated in our counting list. So for 6 there is no counting, there is 0 counting. For 5, 0 counting. 4, 0, that means all are 0. So that means there is no elements lesser than 7 is come in our original sequence. Okay, so if we are starting from the first element 7, so that means we are updating this 7 first time. So there is no element which are lesser than this 7 is came in our original string s.
So basically, all single digits will be part of solution. I
No, no,
mean,
no.
if it is
After that, okay, I'm just complete the solution that you can find the logic completely. So okay, so there is no counting up appeared before the 7 for each element. So okay, there is no count for 0, there is no count for 1, all are 0. So that means we will finally update the 7 value is 1. That means if our string is 7, okay, so total number of subsequence is only 1. Correct? If our string is only 7, that means total number of subsequence is only 1. After that, we are just adding one more. Now I am taking this 5. Now for 5, we will check here. We can take one value for a single 5. Okay, so 1 plus 1. Now we will check, is there any value before the 5 have been updated in our count list? So no, there is no value updated. So that means if we are taking 7, 5, okay, so this one value is only updated, but using 7, 5. So 1 second, yeah, 7, 5, yeah, so that is okay. If we are taking simply 5 here, so there is no value before that. Okay, so only 1 is possible for 5. So we'll increase this 5 by 1. Now 7 is already 1. Okay, this is 1 things. Now we will take the next 9. Okay, for 9. Yeah, so when we are taking 9 value, so 1 is possibility for 9 is single 1. So plus 1. Now after that we will check that how many value have been updated. So 8 is not coming, 7 have already appear in our subsequence. So now we have checked 7, 5, 9. Okay, we are finding the solution for that. Okay, so before 9, 7 we have already appeared, and the total number of subsequence is required for 7 is 1. So that means we will add 1 here more. Same things we will check for 6. 6 is 0. Now 5 is also 1. So we will update 1. So now there is all are 0, remaining all are 0. That means if we are taking this 9, that means 1 plus 1 plus 1. So 3 subsequence are more possible. How it is possible? I think so. 1 second. So 5 is okay. Okay, so 3 we are getting here, and 1 we are getting here. 1 here total. So total subsequence is now is 1 plus 1 plus 3, 5. Okay, so you can simply write these things 7, 5, 9, and 1 is 5, 9, and 1 is 7, 9. Yeah, so these 5 are a possibility. Okay, and last thing, so 8. For 8, if we are adding 8, that means we are just adding 7, 5, 9, 8. Now we are considering for 8. How many possibility are there? So 1 for single 8. Okay, so plus 1. Before that, how many digits have already appeared in our sequence? 7 have already appeared. So that means this combination are also possible. Okay, so for 7, only one subsequence are possible. We have already count. So we will directly read the value for 7 here. So that means plus 1 more possibility. Then we will check for 6. So there is no. Then we will check for 5. This is 1. Okay, so 1 is also. So total 1 plus 1 plus 1, 3 is also possible for 8. So actually we are just looking at how many possible increasing subsequence are possible. We can find out that. So if any value have already appeared in our subsequence before this value, so that means we can write as a subsequence. So 8, 7. So 7, 8 we can write one option. Okay, so 8, 5 we can write 5, 8, 1 as the answer. Okay, and 1, 8 we can also add 8. So that means 5 we have already get from here, and we can add 3 more after adding 8. So this is 7, 8, 5, 8, and 8. So total solution we have received. So after finally we can add these things. So 1 1 3 3. So we can add all these information and return the answer. Total number of 8 subsequence are possible. Okay, so just initialize the one count list from 0 to 9 and then check for each digit which are appearing in our string s, and just increment by 1 for each index. So for 7 we will increment by 1 because we can take single digit in our subsequence, and check that how many smaller value which have already appeared before in our subsequence. So if they have appeared before in our subsequence, definitely they have already updated in our count list. So we can find the number of subsequence using these methods. Okay, so this is the logic. We can find this logic with the different example if you're not getting with this. Okay, is there any sample test case? So, okay. So I'm taking the different example. So s equal to 1 1 2 3. Okay, Bimlis, are you taking this example? Okay.
Yes, I thought we could take this example for explanation.
Oh, but I think this is a big example. So okay, we will check that. So 5 4 6 7 6 6 1 1 2 3 7 8. Okay, so this is the strings, and now we want to check our count. So we will check that count. So 0 0. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we will start from here. So 5 value. So we will increment by 1 directly, and then we will check the element. Those are coming before. So 4, 3, 2, 1, 0. We will check for all. So all are 0. So that means there is no element which are smaller than 5 is appeared in our S. So that means this is the final update. So we can change this by 1. Okay, I'm updating directly here. Okay, so now 4. So we have completed this. Now 4. Same things for 4. So that we will directly increment by 1 here. And there is no element which we have already updated before that. And so there is no element. So we will directly update by 1. Okay, now for 6, yeah, for 6. So for 6, if we can directly increment by 1 for a single 6. After that, so we have already seen that 6 5. So there may be a one combination we can achieve using 5 6. Okay, so because this is a increasing subsequence, so we will add these things here plus 1, and for 4, so there is also a one possibility. 4, so we will add 1 here. That means if we are considering this 6, we can achieve 3 subsequence by this these 3 combinations. So 5 4 6. Using this we can achieve 3 if we are adding 6. So this is the final one, and so total combination we can achieve using this 4 5 6 is 1 plus 1 plus 3 5. How? So we can simply verify this. So 5 4 6, these are the 3, and so increment sequence you can see that 5 6 and 4 6. So we can see that this 5 6 and 4 6. So we are getting this 5 total. Now for the next 7. So if we are updating 7, so there is +1 here. Now for 6, so for 6 we are getting total 3 subsequence. Okay, so we will directly add this 3 here, and for 5 1, and for 4 1. So that means if we are including 7 in this sequence of 5 4 6 7, so our total number of subsequence are possible. We can directly find out this. So this is 6 plus previous 5. 11 subsequence are possible till now. So 1 plus 3. So this is 1 plus something plus 3 plus 1 plus 1. Yeah. Total 6. Yeah. Okay. So if we are adding 6 in our subsequence, so till now we have achieved 5 subsequence. When we are adding 7 in our subsequence, so how many subsequence are more possible? So we can achieve 7 extra, we can achieve 6 7, we can achieve 4 7, we can achieve 5 7, and we can also achieve 4 6 7, 4 6 7, and we can achieve 5 6 7, 5 6 7. So total 1 2 3 4 5 6. So because of that we are adding 6 here. Okay, so just use the same concept, then finally we will get the final answer. So for example 6, if we are adding 6, so 6 is repeating now. So this is the another step. So okay, so we'll check that if 6 is repeating. Okay, so if 6 is repeating, same things, this is the separate 6 from the previous 6. So we will add 1, and then we will check that, so how many previous elements are possible. So 1 plus 1 2. So we will add 2 more for this, plus 2, that means 3. So previous are 3, 3 plus 3 is now 6. So we will update this counting list every time. So finally in the final list we will add all the count value in our list. That will be the final answer.
Could you please repeat for repeated 6?
Yeah, for repeated 6 we have achieved this 3 from the previous 6. After that, this is actually, this 6 is separate 6 in our sequence, in our strings. Okay, so for this we can write separate this 6 6 separately. So there is 1 for the separate 6, and 2 for the this before value. So for there is one value 5 is coming 1, and then there is 4 is coming 1. So that means for this 6 we are also getting the 3 more subsequence. So because of that we are adding this 3 plus 3, now find total is 6. So because of that I am
No,
just,
but strictly greater than, how will that be maintained?
so our subsequence are strictly greater than, our
Yes, so if,
subsequence is strictly greater. So actually if we have a string, for example 1 1, okay, so you can take this one separate and this one separate. So this is the answer. That means 2 are possible. Okay, so for example if you are taking this 1 1 2, so strictly for strictly separate the total subsequence are possible 1 1 and 2, and there is 1 2 for here 1 2, and there is 1 2 for this 1 2. Okay, so this is a increase, strictly increases. The you so these value actually are looking same, but both are the different subsequence, because this one is relating to this first one and this one is relating to the second one in our subsequence. So for this 6, so if we are taking this second 6, so that means we will represent this 6 by separate from the first this one 6. Okay, So for this 6, so for this 6 we can write like this: 4 6 and this 5 6. Okay, this is for this subsequence is for this 6, and for second 6 we can separately write these things: 4 6 5 6, because these subsequences are separate to this subsequence. These below subsequence are we are getting from the second 6. Because of that, I have increment 3 here once again. Okay, so
Got it, sir.
this is 3 from the previous, and this is 3 from the next. Same for the next 6. Once again, we will increase 3. Okay. So yeah, this is the concept to achieve the answer. So very small code is required. Yeah, hi Harshit. So do you have any question? Harshit? You are not audible. Actually, you are mute. Unmute yourself and then you can talk.
Hello, sir. Am I audible?
Yeah, yes, Harshit, you are audible.
This is week 9, right?
Yeah, this is week 9.
Sir, I want to know which type of questions will be asked in quiz 2.
OPP
Is
exam.
it- No, no, not OPP. The
Quiz
quiz
2.
2.
Okay, quiz 2.
Hmm.
Question will be similar of similar type of quiz 1. You have already, if you have already given the quiz 1, so I think you should
No,
know.
I mean the specific topic will be algorithm or
No,
data
conceptual.
structure.
Most of the question will be based on the conceptual. Maybe 1-2 question based on the code.
Okay, okay.
Okay, but code will be the simple code. Not too much difficult.
Okay, sir. Thank you. And what
Okay, the
about the
more
OPP?
for OPP exam, the question will be similar of your graded assignment, live coding assignment, and practice assignment.
Okay,
Okay,
okay, sir. Thank you.
yeah, just learn the algorithms carefully.
So that that thing is very difficult actually.
So, for example, for graph part, just learn the concept of actually learn each algorithm's codes is not possible for anyone.
Okay.
Okay,
Actually, sir,
not
whenever I learned the algorithm, I forgot the previous one
yeah,
and
yes,
get
because
confused about.
yeah. So if you are trying to learning the code or things, if you are trying to learning the code of the algorithm, so definitely you will forget or you will mix up all the codes
Hmm.
concept. So just try to understand the concept of algorithm. Just learn or understand the concept of algorithm. Okay, so so just solve the for example, if you are learning digest algorithm for shortest path, so just solve one example manually using the concept of algorithms. Okay, just take one graph and solve this graph or find out the shortest path manually by on pen and paper using the concept of digest algorithm.
Is there any?
If you understand the concept of algorithm, then you can write your own algorithm codes. So there
Okay,
is no need to remember the codes of the algorithm. You can write your own code.
sir, is there any specific source to practice that manually?
You can make your own question. So that is very simple. Just for example, you have all the test case. Okay, so just get, take one test case and make the graph, and after that apply the concept on graph. So for example, in the digest algorithm, what are the initialization? How we are initializing? We are doing so. Initially, we initialize all the infinite value at each node as a
Hmm.
distance, and the source node we assign the 0 value. After check that how we are updating this value when we are traversing on each node by adjacent. things, how we are updating. So just apply the diasta concept on the graph directly. Understand how we are applying actually algorithm. If you are understanding clearly the concept of algorithm, you can write your own code. Okay, we are also not thinking about this so everyone can learn each code which you are learning in this subject. So this is not possible for everyone, but understanding the concept is possible. So for this type of subject, j- can be easily passed or it can be achieve the highest numbers if you are getting the concept clearly in your mind. You can write your own code. That is,
Actually, I know, sir, how the algorithm works. I know, but when I want to implement it in code, it gets difficult, right?
so currently how you are implementing the algorithms? You are looking the our codes, or you are just trying to write your
Uh,
own code?
Looking your code actually.
Yes, no, that is the problem actually. So that should be the last step. If you are not getting the solution, that is the last step. If you are directly going on the code code which we are providing to us, so that is the no, not the good things. First try by yourself, write your own code. So this is these codes which we are providing you, that are the that not are the standard code actually. So
Achha, achha.
if you are reading any particular book, you will find the different types of code for that algorithm.
Yes, yes, absolutely, sir.
That means, so you can write your own code also.
Okay, I
Only
will try.
concept should be covered. Concept should be covered. Write your own syntax, write your own variable. Okay, that can be easily rememberable. If you are writing your own code, you can remember this code.
But sir, I mean, in the portal, if I use some functions or some libraries like heap, short, as like numpys, it will not allow to take that
No.
libraries.
NumPy, these all things are available on the portal. NumPy you can use.
Okay, then any library we can use, right?
Yeah, any library you can use.
But in Python, I think it was not allowed.
Which library?
That's why numpys and all.
No. Here you can try. You can try in your graded assignment, practice assignment. These are working.
Okay, sir.
Okay, you can. So practice on the portal for coding, not the Replit or not the your local. For the OPP, just practice on the portal.
Okay, sir.
Yeah. Okay, so how many have completed? And okay, so those who have completed problem number 2, you can move to the problem number 3. Yeah. So Sanjeev, Mayank, Mayank is also still trying. Okay.
Can you check my code? I have some errors. So
Okay, I'm coming on the call. Yeah.
not passing any cases.
Okay. Yeah, this is your code. So you are initializing 0 value for the each value. Okay, 10. After that, si int I for okay. So that's correct. For I in S, so that is from S. That means you are reading the digit in S. Okay. So ti minus 1 equal to 1. Why ti minus 1 equal to 1?
That value I'm previously it was a 0. Now I'm just initializing that as 1. Like
No. Actually,
replacing.
there's no requirement for this here. So okay, so we can skip this part right now. So for I in range I minus 1, okay, that is correct. If tj equal to 0, so what is the meaning of that? Okay, so using this loop, just add the value in ti here. So no need to check 0 here. We directly increase the count. So one, yeah, okay, yeah, we directly increase the count, increment the count. Just take the value here, and by increment plus equal to. So this is j. Okay, so tj, tj. Okay, so what this error is coming? Oh, this is condition actually. No need to take condition. Yes, so for j loop, so this is the extra things. This is also extra things. And after the loop, directly increment by 1, because we can take one single digit subsequence also. So increment by 1 only here. Okay, and in the final we will return the sum of all counts. So this is the sum. Okay, just yeah, passed. So this is not required. Yeah, so very small code we have written actually. Okay, so you got it what we are doing?
Yeah, I have to.
Yeah.
Actually,
So for I column, so we will directly add the value if we are, if there are a small number which we have already appeared in the sequence. So we will add all the count number in this ti. After that we will add 1, because we can take a single digit as a subsequence also.
Okay, got it now.
Okay, after that we will return the sum.
Okay, got it now.
Okay. Move to the problem number 3.
Yeah.
Okay, so we are moving to the problem number 3, and this is actually different. Here the variables are more. So we create a structure. Okay. Okay, so I think related problem is also available in the practice assignment in the Beak 9. So that is a similar problem. So you can also solve that problem. So here this is a popular problem called the knapsack 01. Knapsack 01 we call this problem. Actually, I am in Beak 6. It's very difficult to understand at some point in the lecture. Okay. Okay, Harshit. So we will think about it. We can arrange some non-steamed session, so where you can ask your problems separately, In the next week, maybe we can arrange some non-stream sessions. So we will give the time to you. Okay. So this is a popular problem called the knapsack 01 problem. Okay, there is two actually problem, knapsack fractional and knapsack 01. So knapsack fractional problem can be solved using the greedy approach. I think you have already seen in the week 7 in the assignments or live coding we have given that problem. But this is a knapsack 01. So what is the problem is? So problem is you are given weights and value of n items. Okay, so put these items in a knapsack of capacity W. So there is a we can say that there is a we have a one bag of capacity W. So W is representing for the weight. This is the maximum capacity to get the maximum total value in the knapsack. Okay, so actually our main goal is so we can maximum weight we can select is W. Okay, but our maximum value should be maximum for the items. Note that we have only one quantity of each item. In other words, given two integer list value, so we have two integer list value and second is weight, and which represent value and weight associated with n items respectively. Also given an integer W which represent knapsack capacity, find out the maximum value subset of value such that sum of the weights of the subset is smaller than or equal to capacity W. You cannot break an item, either pick the complete item or don't pick it. 01 property. Because of that we are calling knapsack 01 problem. Okay, so I am giving one example. I'll tell you what is the exact problem is. So here we can understand that. So here n is represent total number of items. Okay, 3. So we have a total number of items 1, 2, 3. We can represent like as a nt. So now our capacity is maximum 4. So this is a weight actually, and now we have a two list. One for value. Okay, value. And second for weight. So okay, I'll write the weight first. Weight, that is 4, 5, 1, and second is value. So value is 123. Okay, so we have a capacity 4. We can select maximum 4 weight from these items. Okay, so for example, if we are selecting item number 1, okay, that is representing to this that one is this. Okay, so if we are selecting item number 1, so the weight of the item is 4 and the value of that item is 1. Okay, so value here we cannot break this weight. Okay, so for example, if second item contain the weight 5 and the value is 20, that means we have to pick completely this 5, or we have to skip this 5 completely. We cannot select the fractional part of this 5. Okay, so our capacity is 5. We can select completely 4. If we are selecting this first item, the weight is equal to our capacity, we can select, but we are achieving the value 1 here. Okay, but second things, we cannot select this one because the weight of this second item is greater than our capacity. We cannot select. So okay, we have to skip this. So third item contains the weight 1, which is lesser than our capacity 4. We can select it, and when we are selecting it, we are getting the value 3. Okay, so we can select only 1. After that, what is what the remaining item? When we are selecting this item number 3, so weight is 1. The remaining weight will be 4 minus 1 equal to 3. So now we cannot select any item. Okay, so because we are assuming that every item have a single unit. So if we have selected it, so there are 2 remaining items are So we cannot select it because the weight of that item are greater than our remaining capacity, 4 and 5. So that means our maximum value we can select is 3 in this case. So this is the problem. And so what combination of item we can select to get the maximum value? So the answer is
Sir,
3.
input is N, W, weight, and value, all the 4, correct?
Yeah, input
Hello.
n equal to hello, am I audible?
And we have input will be 4 items.
No, input actually n equal to 3 represent the 3 items.
Okay.
This 3 is representing total number of items. Okay.
Total number of weights in the bag.
No. This n equal to 3 is represent total number of items we have. So we have actually 3 items.
Okay.
Okay, this first value is combination is representing a 1 item. This is a second item. This is a third item.
No, weight and value, these are 2 lists, correct?
Yeah, these are 2 lists.
So what does the combination weight 4 value 1 mean?
So that means we have a 1 item that weight is 4 and the item value is 1. This is the combination. This is the relationship. So we can just take an example. We have 1 pencil. Okay. So for example, we have a 1 pencil box. Okay. So we have 1 pencil box items and the total number of pencil inside is 10. Okay. In box, and the total value for that is for example 20. So this 20 value is representing for all 10 weight. So we can write this like this is a weight.
So we cannot break something, that means in the weight
yes,
list,
yes.
weight we cannot make 4 like 2 plus 2.
No. We cannot break our weight, item weight.
And the input W equal to 4, what does that mean?
W equal to 4 is a selection capacity. Selection capacity, we can select maximum weight value is 4.
But we are not selecting the 4 which is in the weight list. We are dividing.
No, we are actually selecting. We can select this first item because the weight is equal to this 4. We can select, but we are getting the value 1. When we are selecting this first item, we are getting value 1. Okay. If we are selecting the last item, okay, so we are getting the value 3. So this is our main purpose of the problem. We are finding this combination of selection where we are getting the maximum value.
Okay.
So if we are selecting last item, 4 of them, then total value will be 12. Is that the case?
No. We can select only one time. No, see, we can select only one time this item 1 because this is a single unit, and we are getting value 3. After that, our capacity will remain 4 minus 1 is 3, but there is no item available which are smaller than this capacity. So we will leave it.
Okay, sir,
This will be the final answer 3.
Understood.
Okay. So we can select item completely, or we have to skip that item. So we cannot select the part of the items. But our final goal is to get the maximum value. So okay, I'm explaining the structure to solve this problem. Actually, here there are multiple things are given to for the verify. There is one capacity is given W. We cannot select the item which are greater than our capacity. Okay. Second thing, we are just identifying the maximum value. So two parameter or which two condition are given. So because of that, we will create a two-dimensional table for that. Okay. So for example, I'm taking the same. Okay, I'm taking the different example now. For example, we have a weight list 4, 4, 5, 6, 7, 2. Okay, and corresponding value is 50, 40, 60, 6, and 91, and 2. This is the corresponding value, and our total capacity is n equal W equal to 10. 10. Okay, n is representing a total number of items. So 1, 2, 3, 4, 5, 6. Okay, so how we can break this problem into a sub problem? So we will create one matrix. So we will take the column 10 columns. So actually not 10. We will take a one more. So like you have solved the problem subsequence problem in the week, common subsequence, common subword. So in the same things we will achieve the answer for that. So we will create a two-dimensional matrix for that, where W is representing in the by the column and N is representing by the row. So we will take one more value. So we have W equal to 10, then we will take 11 columns. 0, 1, 2, 3, 4, 5, 6, 7, 8, 10. Sorry, 7, 9, and 10. Okay, so that is total 11. 1, 2, 3, 4, 5, 6, 7, 8, 10. And here 0, 1, 2, 3, 4, 5, 6. Okay, we are just taking one extra 0 and 0 for each row and column. After that, how we can solve these things? So for example, how we are just dividing into a sub problems. So this n is representing a capacity. Sorry, this is representing a number of items which we have. Okay, so for this one value, so for example, if we are taking this n equal to 1, that means we are talking about this first item in our list. Okay, and 0, if total number of n equal to 0, so total number of item equal to 0, that means no weight is no possible weight is required. So for this for the first input, okay, one things. 0, 0, 0, 0. Okay, we will initialize with this list by 0 completely. So 0, 0. We have to initialize this list. If we are creating a row and column list, we have to initialize also all value with 0. Okay, so I'm just writing these things.
Why here you're taking weight as 10 and this value as 6?
Because this is given in our question. So we have total number n equal to 6. So because of that, we are taking this 6 values here. Okay, and weight is given 10. Because of that, we are taking this 10 value.
Okay.
Weight is 10.
Okay.
We are also just adding the 0 value because we are just initializing if we have a 0 item. So what is the weight required for that? For each weight, what are the what are the possibility of selection for 0 items? So that is the 0. Okay, I'll explain in the next thing. This is the initialization steps. So this is I'm writing 0 at every place. So 1, 2, 3, 4, 5, 6. One more is okay. So we can start from the first thing. So this is the initialization. Oh, sorry. Yeah. So yeah, this is the initialization. Now this number of this row is representing a number of items, and this W is representing columns is representing weight value, W value, capacity value. Okay. So for example, if we are breaking this big problem as a sub problem. So for example, if we are just reading as a 0 value, so here n equal to 0, that means we don't have any items at this time. Okay, so there is no meaning to get this W value. So everywhere this 0 value will be remain same. So that means we cannot achieve this W weight by any items, because we don't have any items at this time. So this 0 will remain same for the first row. Okay, we will start from the second row and second column. That means we will start from this position. Same things for the first columns. If we have W equal to 0, that means we cannot achieve by this W equal to 0 by selection of any items. So that will remain the same. So we will start from this position to fill. Okay, so when we are filling the first for this row, okay, so this is second row, but here n value equal to 1. So when we are filling this row, so we are assuming that we have only one item at this place. When we are filling this second row, so here n equal to 1, n equal to 1. That means we have only one items. So we are assuming that we have only one item, that weight is 4 and the value is 50. So how we can achieve these all weights? So now we will start. We are assuming that we have one item. Now we will start from the weight 1. So if W equal to 1, can we achieve this using only one item? W equal to 1, that means capacity equal to 1 and our item weight is 4. We
No,
cannot
sir,
select
1, 2, 3 will be 0.
Yeah, so that means we cannot update this thing. So this will remain same for the W equal to 2. We cannot select this, so this will also remain same. For 3, this will also remain same. Okay, when W equal to 4 and we have only one item, so W equal to 4, and then we can select this item completely. And when we are selecting this item 4, we are getting this 50 value. So we will update this 50 value here and for the value 4. Okay, fine. Okay, now move to the next 5. So if we have a 5 weight, W equal to 5, and we have only one item, so we will select this 50, and after selection
so now
of
balance row will be entire 50.
Yeah, so actually we have only one item, so we can select after that only this item. So this will remain 50, because we will, if any remaining weight is available, so we will check the previous list. We will check. So for example, we are selecting for this 5, so we will select the weight 4, and what will be the remaining capacities? 5 minus 1, 5 minus 4 is 1. So we will check the previous value from here. What is the value of 1 is here 0. So that means there is no value is available. So we will add this 0 into our 50. So that will remain same. That will happen for the same all, because we have only one item. So this 50 will update 50, 50, 50, and 50. Okay. So now we have solved one sub problems. Now when we are adding one more n items, now we are adding n equal to 2. Okay, that means till now we have 2 items. Okay, so now we are considering this 4 also, second 4. Okay, so at this place 0, w equal to 0, we cannot achieve this. 0, we cannot achieve this. Okay, we will start from this second column. 0, we cannot achieve this. 3 also we cannot achieve this. Yeah, 4. So 4 we can achieve this by this second items. Okay, but we are getting this 40 value if we are selecting the second items. Okay, just checking for the second, if we are getting this 40 value, but the previous value, if we are not selecting this 4 and we are selecting the previous value, we are getting 50. So we will select the maximum of that. Okay, if we are selecting second item, we are getting 40. And if we have a 2 item 1 and 2, so if we select the first item and skip the second item, then we are getting 50. So we will select the maximum value, because our main goal is to get the maximum value. So if the current value of the selection value is, for example, we will compare this 40 by the previous value, this 50, which is maximum. Okay, this 50 is maximum, so we will select this 50 here.
Sir, this n equal to 2, could you please repeat?
So for example, if we are considering that for n equal to 2, that means we are just considering the second item for the second this column. Okay, now we have 2 items. The first item, that weight is 4 and value is 50. And okay, we are adding one more item now. So that is the second item, that weight is also 4 and value is 40. Okay, now we have 2 items, and now we are finding out the selection for 4, this position. Okay, so I'm removing this part. I am finding out the selection for this.
So n equal to 2 doesn't mean that now we are taking 2 items. We are taking second item.
Second, that means now we have 2 items. Now we have 2 items, and we are just finding out the possibility of selection for all these weights. Now we have 2 items, and our w equal to 4. Okay, so for this row, we will check that if we are selecting this second item, okay, the weight of this 4 is equal to this 4, we can select it. Okay, so we can select, if we are selecting it, we are getting 40 value. Okay, and we have also one more items now, that is the first item. If we are selecting, if we are skipping this one and we are selecting first item, that means if we can select this also, so we are getting value 50. So which one we will select? Okay, so our main goal is to select the maximum value items.
So along the column we are selecting the maximum.
Yes, yeah, so actually finally in that column we will get the final answer. Because of that, we are just compare the selection of the previous problem. Okay, we are increasing these things. So we are if we are selecting second item, we are getting 40, and if we are not selecting second item, we will keep remain with the previous items. In the same columns, we will check the previous value. If this is maximum, we will keep it at the same place. So this 50 will come here. Okay, that means we are not selecting this. We are not selecting second. We are going to the first select at this one selection at this place. Okay, move to the next thing. So for 5 exams, so for 5 same things, this will remain also same 50. Okay, for 6 they also be 50. Now 7, this will also be 50. Now for the 8. Okay, now see, now we have w 8. Okay, we can select n equal to 2, we are getting 40. And what are the remaining weight is? So remaining weight is 8 minus 4 equal to 4. Now we will check the solution for 4. So our solution for 4 is 50. So we will add these things. So we will 40 plus 50. This will become 90 here at this place. Okay, so for if W equal to 8, we can select second item, and after that remaining weight is also 4. So we can select first is. So we will check the solution which we have already calculated for the 4. So we will check for the 4. This is a solution we are getting 50. So we will add all these things. So 50 plus 40 is 90. So now at the time of selection 90, we will compare this value of the previous column value. So this is greater than this 50. Sorry, this is greater than this 50. So we will update this is 90. Okay. So
For weight 8,
yes,
we first selected now we are
second
in
item.
n equal to 3. Sorry, we are in n equal to 2, correct? So
Yes, n equal to 2.
we are first selecting uh,
Yeah, second item.
weight 4 from n equal to 1 or weight 4 from n equal to 2.
Second item. If we are moving, if we are going for the row which contains the item number value 2, so at the time we always select the second item first. If any weight is remaining, then we will check the solution for the for remaining weights.
Correct. So in n equal to 2, we when we went to weight 8, then we first selected
The
4 equal
second
to
item.
40. 4 equal
Yes,
to
yes, yes,
40. And
yes.
then we out of the capacity we reduced this 4, and
Yeah.
then we got balance capacity 4, which is
Mhm.
available in n equal to 1.
Yes. So we will check the remaining. We will check the value for the remaining weights. So remaining weight is 4. So we have already calculated for 4. This is 50. That, and then this 50 is coming by the selection of this one. Okay. So we have taken this by here. So that means in that case we are selecting item 2 and 1 both. Because
In
of
that
that we are,
sequence.
yeah.
Okay.
Okay, so 90. Same for the W when we are for the W value equal to 9. So same we will select first 4, then the remaining weight is 5. Okay, so we will directly check the 5 solution here. That is coming from here. Okay, so same things 2, 1, 90 will also update here. And 10, same things 90 will come here. Okay, so now this is complete. Now for n equal to 3, n equal to 3. So for this row, same things. If 0, 1, 2, 3, we cannot. So total weight is 5. We cannot achieve this. So this is okay. Yeah. 0 and 4. So for value W equal to 4, if we are this value is lesser than, so which we will select the previous value. If previous value is greater, so we will remain the same here 50. Okay, because if we are not selecting 5, we can select the previous value for this one. So we will keep the same, which is maximum. And if we are taking W equal to 5, W equal to 5, now we can select this one. Okay, so we can select this one, and if we are selecting this one, then we are getting 60 value. And this 60 value is greater than the previous value 50. So we will update this here 60. And after selection this, there is no remaining weight. 5 minus 5 is 0. So that means there is no required to check. And we will move to the next 6. So for 6, we will select this item first. Okay, and we are selecting this one, then it will remain the 60 because this is greater than the upper selection. And the remaining weight is 1, so there is no solution for 1 is okay, so we will keep remain same. And when we are getting 7, so same 60 value come here. And when we are getting 8, now W equal to 8. Okay, so for W equal to 8, then we will select first item is this one. So this is 5. We are getting 60 value, and after that the remaining weight is 3. So there is no solution for the 3, that is 0. So that means if we are selecting this item, third item, we are getting 60, but we have the maximum solution by the previous one. If we are selecting this 4 and 4, we are getting 90. Okay, so we will not select this third item. We will go with the previous selection. Okay, so we will write this 90 here from the previous solution. Okay, for the 9 now, yeah. So okay, for if w equal to 9. Okay, so if w equal to 9, we can select 5, 60. So that means 60 plus. Now the remaining weight is 9 minus 5 is 4. Now we can select. We will check the solution for 4. So solution for 4 is 50. So 60 plus 50 is 1110. Okay, so 1110, and the previous selection was 90, and we will update this by 1110. Same for the 10. So if we are selecting 10, so we will select this 5 1, and then after that we can select only 4, and after that there is one value remaining, so there is no solution for 1. So same for this is so 1110 solution will come here. Okay, so using this way, we are just updating all the weights, and in the final things we will find out the final result. So okay, we will move to the first. So for example, if we are including this 4, so if n equal to 4, yeah, so that means we are considering this now. Yeah, 6 item. Okay, so that 0 will remain same, 0 will remain same. Okay, till 3, 0 will remain same. Now 4, okay, so capacity is 6. Okay, we will go with the previous one. Now for 5, so now we cannot select this, and we will go with the previous one, 6, 60. And for 6, we can select this 6, but we are getting the value 6. Okay, but which is very smaller than the previous one. Then we will go with the previous one selection. For 7 value, same things. If we are selecting this 6, we are getting smaller value. Then we will go to the previous solution 6. And for the 8, if we are selecting this 6, we will get 6, and 8 minus 6 is 2. So there is no solution. So we will go with the previous solution. And 9, if we are selecting 6, the remaining weight is 3. So there is no benefits to selection this. That means this is 1110. And for the 10, if we are selecting 6, okay, we can select 6. After that, the 4 weight is remaining. So 6 plus 4 weight is 50. So 6 plus 50 is 56, but which is lesser than the previous selection. So 1110, that will remain the same. Okay, now we will increase the next item. N equal to 5. Now item is this, 5th item is this. Okay, so for the first initial value, we cannot achieve this till now 0, and after that this will remain 50, this will remain 60, this will remain 60, and for 7 we can select this 7. Okay, if we are selecting the 7, we are getting 91, and the previous one is 60. So we will update this for 7, 91. Okay, and for 8, if we are selection this 7, we are getting 91, and the previous one was 90. So we will select this 91. For 9 also, if we are selecting this 91, okay, so previous one is 1110, so that 1110 will come. And for 10, if we are selecting this 7, 91, and remaining is 3, so there is no solution for 3, so we'll keep with 1110. And now final is 6. So okay, so if we are selecting this 2, yeah, so now we have weight 2. So this 0 will be remain, this 0 will be remain same. Okay, 1. Now we can select here 2. So if we are selecting this item 2, we are getting 2 value. Okay, so we will update here 2. Same for the 3, we can select only this. So this 2 will also come here. For the 4, so we will not select this because we are getting 2 value. We will go with the previous selection. So this is 50, and same for the 60. 2 weightage. Okay, yeah, okay. So for 5, so if we are selecting 2, remaining weight is 3. Okay, no selection. Yeah, for 4, yeah, for 6, if we are selecting 2, we are getting 2, and the remaining weight is 4. So for 4 is 50, so 50 plus 2 is 52, but the previous one is the 60. So we will go with this. Now for 7, so for 7, same things, 2 and 5. So 2 plus 5 solutions, 62, 62. This is 91. Okay, so we will go with this. So for the same, for the 8, if we are selecting this 2 plus, and what are the solution for 6? This is 60. Okay, that is also 91. Now for 9, so we are selecting this 2, and the remaining will be the 7. 7 is 91. 91 plus 2 is 93, but previous is 1110, and same for this is 1110. So in last row and last column combination, we are getting this 1110 value. That this will be this is a answer. That means if we can select, we can get the maximum value 1110 by the selection of. So how we are getting this selection is using this 4 and 5 combination. This is the maximum selection answer we can achieve. So this is the way to solve this knapsack problem. Just initialize the matrix by 0 and apply this process.
So as we are increasing n, basically we are iterating through the weight list.
We are increasing n, so that means we no, okay. And actually we will increasing, and that means we are adding the items, and if we are adding the items, then we will find out the maximum possible selection to get the maximum value which are available. So in the possible items, so for example, if n equal to 1, that means we are finding out the maximum value selection for only one items in this row.
Okay.
So in row we are increasing the number of items, and in columns we are finding out the solution for each weight w. Okay, just try to write the code for this. Okay, I'm explaining the solution for this. I've written the code. You just look it, and the next problem is exactly similar to this problem. Approximate code is exactly similar. Okay, just try to solve this one. Just understanding this problem, knapsack. So initially we have created one empty list st. After that we have created the two-dimensional list. In this part we are actually creating a two-dimensional list of size n+1 rows and w+1 columns, and we are initializing this by 0. So this is the initialization part which we I have explained in these things. So here we have created one matrix and of the size of n+1 rows and w+1 columns, and we are initializing with 0. Okay. After that, we am applying this logic which I have explained in the previous example. So this is the things. So this part is the actually initialization part. After that, I am just starting from the first row and first column. That means index 1 row and index 1 columns. Okay, so that means I am starting from this value from here. Okay, so I am starting from this position. Okay, same things in that way. So row by row, I'll fill this matrix. So how I'm filling this matrix? So for I in range 1 to n+1, that this is for row and this j is for columns. Okay, so for each row we will calculate the value for each columns. So if weight of I-1, here I am mentioning this I-1. Okay, if we are starting I equal to 1, then this one value is actually representing a first item. But in our weight list, the first item at index 0. Okay, because of that I have taken this I-1 here. If I value is 1, that means we will take the value from 0th index. Okay, so here I am mentioning this I-1. If the weight of the I at I-1 is less than equal to j, so this second loop is representing a weight. So if our weight of item is less than equal to j, that means we will select that item. Okay, so if we are selecting that item, so we will check that the maximum value. For example, if we are selecting that item, so we will add these things. So this is the item. Okay, so this is the value of item, and plus what are the remaining weights are available after selecting this. So because of that I have added these things st I-1. So okay, so here we are just calculating the value of I comma j. So this part actually I'm selecting from the previous row, because we have already selected the item, second item. Then we will select the we will get the value from the previous row solution. So because of that I mentioned this I-1. That means the previous row we will select the value of j minus. So this j is the total weight, and minus weight of the item which we have selected. So we are reducing that. That means we are just calculating the remaining weight here, j minus weight of I-1. So we will directly pick the value of the remaining weight. So after adding these two value and comma st I-1 comma j, that means in the same columns we will select the previous result. So we can understand by this. For example, at this place, for example, so if we are selecting the item number 2, okay, we are selecting the item number 2. So what we are doing, we are selecting this, we are getting 40, and what is the remaining weight is, so 8 minus 4 is 4. So we will directly see the solution from here. Okay, because in this row we have selected item already, so we will directly show the solution of the previous previous row solution. So this 50 plus 50, we can also see the solution from here. Okay, so I think this may be cause a problem in some case. So we will select the solution from the previous row. That is the sub problem solution. So 50 plus 40 is 90, and we will compare this by previous column value on the same so previous row value on the same column. Okay, So if we are getting 90 and the previous column value is 50, so we are comparing the, we will select the maximum value. So because of that, I have written this max here. This is the current selection part, and this is the previous solution which we have calculated in the previous row. So which is the maximum, we will select the maximum value and assign these things. Otherwise, if weight is of I minus 1 is less than equal to 0, so if L in the else part of that, we will directly initialize the value sti comma j, the previous row value of the same columns. So you have already seen this thing. So
else part is basically weight is not matching.
yeah, if weight is not matching, that yeah, weight is not matching. Yeah, weight is greater than our capacity. So we will just keep with the previous solution or of the same columns. So we will write the value of the previous column in the same previous row in the same column.
Can we could you please explain line number 11 once again?
So line number 11 is basically here in this part. If you see the first part, these things. Okay, so we are selecting a items for so this is I is representing a row. Okay, I is representing a row. So we are just selecting a items here. I minus 1 is I am writing because our index is 1 less than our item sequence. So for example, if I'm going here n equal to 2, okay, the second item in our list is this. So the index of this item is 0 1. This is 1. Because of that, I am writing this n, so I for this, so I minus 1 for selecting the second item. Okay, so in our code, yeah, so for first value, this value I minus 1, I am just reading the value of the our ith item in our value list, and we are adding the value for the remaining weight. We are adding the value for the remaining weights using this part. Okay, there is a possibility if we are selecting this item, so maybe this item weight is less than our j, and there are some remaining weight is also available. So we will directly read the solution. We will directly read the value from the previous solution. So st I minus 1.
This j minus weight I minus 1, what are we doing here?
Yeah, so here actually we are reducing. So here we are calculating the remaining weight. So this j is representing a total capacity, and we are reducing a weight of our selected item. So in example, you can understand. No? So here so in this case, n equal to 2. That means we are selecting a second item. Okay, and our capacity is 8. That means this is a j value. This is a j value, and this is a I value, and we are selecting a second item. The weight is of the second item is 4. So we will reduce this j minus weight of the second item 4. So that, and what is the solution for that? So we are finding the solution for remaining from here, previous row, and this one, this value we are reading from. So 40 plus this remaining weight solution, which we have already calculated in the previous solution. So we are just directly reading this value.
That j minus weight I minus 1 cannot be outside the index range, correct?
Yeah, it cannot be outside the index range. Okay, so we are actually starting from the 1, and we are just, so every time when we will reduce the remaining things. So for example 8, and our capacity 4, this is 4, so
yes,
8 minus 4 will remain the smaller value. Okay, got it?
yes, yes.
Yeah, so this is the weight we are directly filling. If weight is less than our capacity, if weight is greater than capacity, then we are directly reading from the previous row value. So after that, in the final calculation, after that, we will return the last column and last row cell value. That will be the final solution. So just try to solve the problem number 4, which is approx exact similar to this problem. Just find out this scenario, how you can solve this problem. Okay, so for problem number 4, do you want to try by yourself or want to discuss? Because that is exact, I think you should try by yourself.
We can try, otherwise we can ask in subsequent.
Yes, you can ask. So in the next week, we will conduct 2 revision session, one for the week 5, 6, and next for the 7, 7, 8. So 2 revision session.
And there is one more question 5, which we have not published, I think.
Yeah, there is I think so that problem is not configured on the portal. So okay, I will publish here, and I will also configure on the portal. You can also try, but I think the logic is a little bit tricky for that. So okay, there's no problem. So I'll publish also. Okay, I'm also publishing here on the Replit, but on the portal I will publish later.
And if possible, can you discuss PPA2 week 8?
PPA2. Okay, 1 second. PPA2. Karatsuba. Okay. So have you implemented Karatsuba algorithm separately?
Not separate. I mean, how it was given here. I'm trying.
Actually, here this problem is just divided into the separate part. Okay, so for solution for solve this problem, just implement the Karatsuba algorithm first. After that, this where1, where2, where3, where4, where5 is just a different part of the Karatsuba algorithm. If I saw the Karatsuba algorithm, okay, 1 second, PDS, GitHub. Divided approach. Yeah, so you can see this is a Karatsuba algorithm. Okay, so here actually we are calculating many parts. So XH we are calculating separately, XL, H, YL. Same for this, we are getting this 3 value from the recursive call PQR. Okay, so in that problem, actually we are just you have to creating a function. So where is this problem? Yeah, Karatsuba. Actually we have given these things, and you have to return this value where1, where2, where3, where4, where5. So you have to identify actually in the final one, add plus AD plus BC, Karatsuba where1. So you have to just identify what value should be written in the where1, where2. So it should follow the concept of this Karatsuba code. Just match this given function by this Karatsuba implementation. Okay, which parts you should return? So I think
so basically it is recursively calling Karatsuba, but then the return all the values of Karatsuba should be unfolded in the that function which is required.
yes. So that is the actually first implement this algorithm, then you will get the idea or the concept of this algorithm. Then you should try this Karatsuba. So both are actually similar, but the way of the implementation is different only.
Right.
Just check that return. So this is the same equation, 10 multiplied to into where 5. So this is I think similar to this final this one. So just check that what are these value R, Q, P, which are returning by this all the functions. Okay, just pass return these value in this code. Here we are using where 5. Okay, so this where 5 should be actually this P value, sorry, N value. No, so
Yes, sir.
n value, no? So okay, so 1 second, we can compare these things. It will p into 10 to the power n. So no, so 10 to the power, the sum equation is, I think, different. Or where AD plus BC. Okay, so yeah, you have to, I think, match these things. So how this returns things is AD plus BC. Okay, there is one more equation we have created upper set. So AD plus BC karasuba where comma where 2 minus where 3 minus where 4. Okay. So actually we have to finding out the similarity of these code and of the implementation code. After that, we can return the exact value by the function. Okay, just try to implement this one and then try to solve that one. You will get the similarity.
Okay.
Okay. So B9 PPA1 we have already discussed. So that is the similar knapsack problem based person, and try to solve the PPA2. That is also a good DP based problem. Maximum profit activity. Okay. Okay. So try to solve the remaining problems, and if you will face any difficulty, you can ask in the next session also. Okay, so anyone, if you have any doubt, you can ask or shall I closed?
Sir was explaining this subsequence. There it was getting. I mean, in the lecture I was getting a little confused, but then
Which subsequence? Okay, 1 second, I'm moving to. Actually, there is one
in
mistake.
week nine.
Okay. So in video, there is one mistake to filling the matrix. And I think so one message we have populate at that time. So this is weak.
Yes, one pop-up comes.
Yeah. So where is the peak? So subsequence is the this is the longest common subword. Yeah, this one. Yeah. So what is the confusion?
No, confusion is like how he was explaining. I was not able to capture that till previous. That is longest subword was okay. Here I was getting a little
Yeah. So
confused.
longest subword is exactly continuous subsequence, continuous sequence. We cannot ignore any character in between.
Yes.
But in the subsequence, we can ignore any character from between. Okay, so for example, SEC, if this part is matched from the first part of the one strings, and we can skip the some character from it. After that, T is also matched. So that is a subsequence things.
So
But
how are we like this yellow line? How are we doing this?
okay, so there is one inductive structure. So to fill, you should I think remember this inductive structure. We are filling this matrix using this inductive structure. If AI equal to BJ, just increment by 1 LCS corner. So this I plus 1 comma J plus 1, that is the corner value plus 1. Okay, so okay, I'm just I cannot write on that. 1 second. And we have inductive structure. Okay, so we will start from the lower side. Okay, and then we will match from the last character. So this is a one string. So for example, this is a string. Okay, this is a B string. This column is representing a B string. Okay, so we will match the character one by one. So we are starting from here. Okay, after that we will match a5 by so what are the index of this is b5. If a5 equal to b5, okay, so this t is matched with this t for filling this value. Actually we are starting, so this is the initialization part, this is the initialization part, and this column is also filling by 0. After that we will start to fill the value from this field, and for this field we will match the respective row character and column character. So we will match this t and this t, so this is equal. If any time the row character and column character is equal, so we will increment the value from the lower value. So at LCS I plus 1 j plus 1, that means this representing a we are filling this part, so we will read the value from the diagonal lower value.
Correct.
Okay, so 0 plus 1 we will increment here. Okay, if value are not equal, then we will follow the second inductive structure. So this is for not equal to. In that case, we will just check the maximum value of the on the right field or the below field. In two value we will find the maximum value. Okay, and we will copy the maximum value in this field directly. So for example, in the first case the value are matched, so we increment by 1. Okay, now move to the second. So for example, to fill we can fill
Now in column 5, all other previous rows, I mean 0 to 4,
yes,
for them there's no match. So
yeah,
it is because 5 is filled with 1, we are filling everything else
yes,
as
yes.
1.
So we can fill this matrix either in we can fill either by row wise first, okay, or we can select a column wise also. We can select, we can fill in any way. So for example, we are filling columns first. Okay, so we move to this one. So for this one, this C value is not matched with this T. Okay, so we will just pick up the maximum value of right and lower. So this 0 and 1, which is the maximum value 1. So we will keep it here 1. Okay, same for this one, E and T is not matched. So we will select the maximum value of this two value. So this is 1. Same for this 1. Same for this 1. And because value are not matched.
Yes,
After
correct.
that.
Similarly, row
Okay.
number 5, balance
Yeah.
columns.
So yes, for this one, same things. Now here, now the lower value is 0, right value is 1, the maximum value is 1, then we are filling this 1 because T and E are not matched. But here you can see that this E is matched with this E. So for this case, we are just adding plus 1 here, plus 1 in the diagonal value. Okay, so every time if value are not matched, we are selecting the maximum value of the right one and the lower one. If value are matched, we are incrementing by 1 of the diagonal lower value.
Okay, sir, got
So
it.
we will fill these things. After this yellow line actually represent the way of the finding out the subsequence things. How we can find out this
No, the sir
subsequence.
said like in uh, row 1 and row 0 and column 0. These will be 4 only. Why? Because even though it is not a match, but it is previous to the match, something like that.
Which row? This one.
This here, BI,
BI. This is 4.
it will be 4.
Yeah, actually, we will fill completely this matrix on the same inductive structure. So finally, we will get here the final answer, maximum length of the subsequence. This is representing a maximum length of the subsequence. Okay.
Okay, so 0, 0 will represent the maximum length of the subsequence.
Yes, yes.
But to find the subsequence,
Yeah, so for
we are
find the subsequence, so I'm just telling the process. We can find the subsequence characters. So we will start from the this row, okay, and we will check the right value and the lower value. If any value is similar, we will move to that side.
okay. So
Okay,
4,
so
4,
for
4,
yeah,
we
so for
went.
4 the lower value is similar. We will move here. Now we will check the both value right and left. So now the value is similar. We will move here. Okay. Now the value of the right and lower is not similar. At that time we will move to the diagonally.
Diagonally.
When we are moving the diagonally, we will read the value of this position. So this is a
Okay.
S. Okay. Now we have reached here. So same things, right and lower value is not similar. So we will move diagonally. We will read this value E. E.
Got it, sir.
Okay, same things here. Now for same thing C, and now we have reached the 1. Now the value is similar here. We'll move. Now value is similar here. Move. Now the value is different on the both sides. We will move here. So we will read this T. So this is T. So this is a common subsequence. So we can find out these things.
So suppose it could be a situation that there are two such substrings of the same length.
Two substring of same length.
Two same length, two subsequences. In a word, two words, there could be a situation there are two subsequences of the same length.
Yeah, so more than subsequence are possible. So that is one possible answer. We are not saying that this is a exact answer, because in that way we can find out the one possible answer.
Okay.
Okay, so if more than one subsequence are possible, definitely we will get the more value. So this 4 value we are getting here. So maybe we will get the this 4 value at the another place also.
Okay.
Okay, so
Got it, sir.
we can traverse that one also.
Okay, sir. Thank you.
Okay, basically this algorithm is returning a length of the maximum subsequence.
Yes, sir.
So you can remember this inductive structure. That is very useful to return the solution quickly. Otherwise you have to learn the whole.
Yes,
So
sir.
just
Now it is clear.
yeah, just learn this inductive substructure. Okay, any other query from others? Akars, Sanjeev, Sweta? Okay, so try to solve the remaining problem. So one problem is remaining from the live coding, and you can also try the practice problem. Okay, thank you everyone.
Thank you for the session, sir. Good night.
Good night to all.
Thank you, sir.
Okay, thank you.